This video is for class 8 physics and today's topic is consequences of liquid pressure. So the first one, thickness of walls of a dam is increased towards the bottom. So that means if we go down, you see the thickness of the wall has increased compared to the topmost portion. The reason is that the pressure at a point due to the liquid increases with the increase in the height of the liquid column, which also means as we go down, okay, the pressure given by the liquid on the object increases, hence the wall of the dam at the bottom should also be thicker to withstand that pressure. So thickness of the wall of a dam is increased towards the bottom, increased towards the bottom, so as to withstand the increasing pressure of the water. The arrows in the figure show the increasing pressure towards the bottom of the dam. They are talking about these arrows, okay. They are talking about these arrows. You can see the topmost arrow is smaller and the bottommost arrow is bigger, which suggests that the bigger arrow suggests that the pressure is more. Okay, the next topic, do you know box. Number one, liquid seeks its own level. The height of a liquid, the height of level of liquid in tubes of different area of cross section. You can see the shapes are different, so therefore the areas are also different. Although the volume of the liquid in different tubes are different, see since the size of each tube is different, so the volume of the liquid inside that container will also be different. For example, here this container will this container will hold less water compared to this container. It can hold more than C. Since the volume is different, so the level also should be different. Is not so. Why? Because liquid can flow and hence it will adjust to make a same level. If you see this here, the level is same, okay. The height in each container is same, provided they are connected with the common tube here. They are paired with the common tube here and their ends are joined in that common tube. Okay, let us see why does this happen. Okay, because the liquid can flow, if you pour liquid from here, from A, if you pour liquid from A, then what happens, the liquid goes in from A and flows in the tube and goes to B and then goes to C and then goes to D and then goes to E. Eventually what happens, they will hold the same level, and this is called hydrostatic paradox. Okay, this is called hydrostatic paradox. This phenomena is known as hydrostatic paradox. Okay, number two, if a body is immersed in a liquid, the pressure of liquid on the bottom surface of a body is more than at its top surface. Okay, due to this difference in pressure, a force acts on the body. The force equals to difference in pressure into area of surface of bottom. Okay, this I have to explain in the upward direction, which is called buoyant force or upthrust. Okay, we have studied about buoyant force and upthrust in the previous chapter. Why does that happen? I think we have studied that also. Now this is a little bit of addition to that. Okay, let us discuss this. I want to explain it in the plain paper. Let's see. Okay, so what happens is, suppose we take a container. Okay, suppose we are taking one container. Let me change the color. Okay, I think blue will be better. If you take a container, right, and this container is suppose filled with water, okay, water or any kind of liquid, and in this container we are immersing one object. Suppose let us immerse one object. Okay, this object here. Okay, and when we immerse this object here, this object will feel pressure. Since the object is feeling pressure, okay, you see the water above this surface, the water above this surface and the water above this bottom surface is not same. This height, the first one, this height h1, let us see h1, H1 is less than H2, suppose we consider this as H2, right, and we consider this as H1. So what happens is H1 is less than H2, so so obviously the bottom of the container or the object will experience more pressure compared to the uh, upper surface of the pressure. So because of this difference in the height and the difference in the pressure, so if you consider the topmost surface is getting pressure P1 and the bottom surface is getting pressure P2, then in that scenario what happens is the pressure will also be different. So obviously P2 is more than P1 because H2 is more than H1, right. So pressure at the bottom is more than pressure at the topmost surface. So because of this difference of pressure, actually the upthrust occurs. So this you'll understand when you go to class 9 properly. Okay, that's why it is in the do you know box, right. Okay, coming back to the same page now, number 3, pressure at any point inside the ocean or sea is much greater than that at its surface, because as we go deeper inside the sea the amount of water above us increases, hence that water will exert more pressure. The pressure increases with the increase in the depth. That is why deep sea divers wear special designed swimsuits to counter such high pressure. Okay, so I hope this is clear. Right, in the next video I shall talk about atmospheric pressure. Thank you so much.